Hello everyone, I am Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating System. In our last video, we have understood about introduction to semaphores. So you all have understood like what is semaphore. I'll quickly revise that one. Semaphore is an integer variable which is shared by two processes, which can be shared by multiple processes, and it can accessible by only two operations, that is wait and signal. And mainly the semaphores concept is used to achieve mutual exclusion. And we also understood like we will be having two types of semaphores, counting semaphores and binary semaphores. Binary semaphores are also called as mutex locks. Okay. From this lecture onwards, we will be understanding solutions to some classical problems of synchronization. We will be understanding three classical problems of solutions, the synchronization. First one is bounded buffer. Second one is readers writers problem, and the third one is dining philosophers problem. In this lecture, we will be understanding about bounded buffer, which is also called as producer consumer problem. You have been already introduced about this producer consumer problem. You can recollect while learning about the critical section problem. We have understood what is this producer consumer problem is and how this can be resolved. uh, Producer consumer problem is nothing but you will be having one common space called buffer, where producer will be placing the items in the buffer, and from that buffer consumer will be consuming the items. Okay, now in this lecture we will adopt the same problem, which is producer consumer problem. This can also be called as bounded buffer problem, and we will give the solution to the synchronization using our semaphores concept. Now, before proceeding, you need to understand some terminologies that will be used in this. The terminologies are, make a note of all the terminologies here. We need to consider a buffer which is of a limited buffer, which is bounded buffer. Like you should not have infinite values can be stored. It is not like that. Finite amount of values can be stored in the buffer. So if you are considering n buffers, n values can be stored. Like that, a buffer is required. So what we will do, let us take a buffer of size n. So all these are initial values which are required for our understanding. Make a note, all of you. N buffers are used, and each buffer holds a value. For our example, let us suppose if n value is equal to 5, then it can hold 5 values. All right. Next, it requires 3 semaphores to be used in our approach for the solution. We will be using 3 semaphores. So let us understand what are these 3 semaphores are. The first semaphore is mutex. This semaphore will help us in achieving the mutual exclusion. And it's here this semaphore is a binary semaphore. This is a binary semaphore, and its initial value of mutex is 1, which specifies there is no process in the critical section. Here for this producer consumer problem, the processes are, one process is producer and the other process is the consumer. So initial mutex equal to 1 means there is no process in the critical section. The next semaphore we will be using is full, which is a counting semaphore. Counting semaphore may range to unrestricted value. Okay, as per in this example, if you consider this counting semaphore may range from 0 to a value like of our value buffer sizes of 5. If you are considering n value 5, the full value may range from 0 to 5. So this will tell us this counting semaphore full will tell us how many values are there in the buffer. or we can tell how many buffers are filled. So its initial value is full equal to 0. Initially the buffers are empty, so no buffer is filled, so it has been taken as 0. One more semaphore is required, that is empty. This is also a counting buffer semaphore. This will tell how many buffers are empty. Initially no buffer is filled, so the empty value is n. So all the buffers are empty only. So the empty value is n, or as per our example, the empty value will be 5, because we have considered n value as 5. I hope you all are clear till now. So these are the three semaphores that are used. Mutex, which is a binary semaphore whose value can be 0 or 1, and full and empty whose values may range from 0 to 5. Now let us consider a small n buffers. That means let us consider a buffer like this. This is one buffer, and let us consider another buffer, buffer 2, and then let us consider buffer 3. Because we have taken example of 5, let us take 5 buffers. Fourth buffer, and then fifth buffer. So 5 buffers are taken. Now here the task is producer will be producing the items. Here let us consider two processes. First process is the producer, second process is the consumer. Let us call the producer is replaced with P and consumer is called as C. Now the producer task is to produce the item and place it in the buffer, and consumer task is to take the items from the buffer. And this is our buffer, whose value is size is n of value 5 we have considered. Okay, now we will be using our same wait and signal. Do you remember in the last lecture we have understood? Right. So how the wait will be? I will write here the wait operation. Wait will work like this. Wait. It will take the semaphore value, whatever we are passing, and it will check while wait value, the signal value, semaphore value is less than or equal to 0. It has to do nothing, or else if the condition is false, it has to decrement the semaphore value. This is the wait. And the signal operation is very simple. It also takes the semaphore value, and what it does, whenever a semaphore is called with the signal value, it will just increment the semaphore value by 1. So this is what we have learned in the last lecture. These two operations are required for our task. These two operations are required, so we need to have a track of these two functions. So signal and wait are required. Okay, now let us make a note of this producer logic and the consumer logic, and we will see how they are working. Okay, so the producer logic is like this. Make a note, all of you. Producer. Producer will be doing the task like this. While true, always any process can enter into the critical section. So what the producer will do, it will first produce an item and places it and stores it next p variable. Okay, after generating that item, it has to place that one in the buffer. But before placing it in the buffer, it has to execute wait of empty, and then it has to execute wait of mutex. And then it will go into the critical section, or we can say that critical section as add Next, produce item into the buffer. That is our critical section. Okay. And finally, what it has to do, it has to execute signal of mutex and then signal of wait. Sorry, signal of full. This is the logic for the producer. This is the code snippet for the producer. We will understand how it will work also. Okay. Let us make a note of consumer also, consumer logic also, and we will see how consumer code snippet is written. Okay, so keep your heading all of you here, consumer. So the consumer code is like this. While always true, and it will be checking, it will be executing wait of full first, and then it will execute wait of mutex, and then it will remove the item. This is our critical section. Remove item from buffer and place in next consume variable. This is the critical section of the consumer. After that, the consumer has to execute a signal of mutex and then signal of empty. Let us understand with this code snippet whether the producer and consumer could able to achieve the mutual exclusion or not. Okay, so what we will do, let us take the producer. We will see, take this one. Let us take producer wants to produce the item. Okay, producer wants to produce the item. Okay, now whenever producer wants to produce the item, it will start executing this one. So it has it entered into here. It has produced an item. Let us call in next p is the variable where he has placed its value as 10. Okay, now it will start executing this one. Before placing this 10 value, next value into this buffer, it has to go execute this wait empty. What is empty value? Empty value is initially what? 5. Right. So let us take that one. Empty value is initially 5 as per our example. Full value is 0 and then mutex value is 1. Mutex or in this is only the semaphore, okay, is initially 1. Now what happens? Empty of sorry, weight of empty we are calling, empty value is 5. So whenever we are calling weight, it will go here. Okay, weight of, what is the value we are getting? We are getting the value of 5, right? Now come here. While 5 is less than or equal to 0, which is false, so it will come here. The semaphore value has been reduced to 1. So the empty value, so the, what is the semaphore value here? That semaphore value belongs to this empty. Okay. So what I will do, erase this one. It will confuse you. Okay. Got it. So we are calling empty. Now empty value is of for yes. Yes value has been decremented. That means we are calling with empty. The empty value has been decremented by 1, which is 4. After executing this statement, the producer from here, it will go back to here and it will start executing the next statement. What is that? Weight of mutex. Mutex value is now 1. So the semaphore value is now 1 and 1 is less than or equal to 0, which is false. It will come inside this one. The semaphore value will be reduced to 1. That, what is the semaphore here? Mutex. So this value will be now changed to 0. After that, producer is in the critical section. What is this task of producer? Placing the next p, what is 10, that into the buffer. Now when producer is in the critical section, we have to understand the consumer, if it wants to remove the item from the buffer, is it able? Whether it could able to do that one or not, we have to see. Okay, let us see. Consumer has started executing the task. Okay, consumer is here. Now consumer is here. Now this statement is executing. What is that? Weight of full. What is full value? 0. Right. Full value is 0. So weight of full months. Now this value is 0. Okay. 0 is less than or equal to 0, which is true. Now what happened? The consumer has been blocked here. Did you see why we are doing this one? Because the producer is working with the buffer. The consumer is not allowed to work with this buffer. Isn't it or not? Working with the buffer is our critical section. So when the producer is placing the items into the buffer, we want to block the consumer. That is what we could able to successfully do here, where the consumer has been blocked. I hope you are understanding. Okay. After adding the value into the buffer, the producer has completed its work. Okay. The producer has completed its work and it has come here and it has to execute this statement now. What is the statement? Signal of mutex. What is the mutex value? 0. Signal of mutex is 0. Sorry, this one. Signal of 0, 0. Now what happened? That value has to be incremented by 1. That means the semaphore value mutex has been incremented by 1, and then it will execute this statement. What is the signal of full? What is the signal of full? Signal of full means full value is 0. 0 will be sent here. That means the full value will be replaced with incremented by 1, which is 1. I hope you all are understanding. Okay, after this one, now consumer who is waiting here, it keep on checking. Consumer again will execute weight of full. What is full value? 1. Now the consumer will get a value of 1. Okay, 1 is less than or equal to 0 is false. Now what happens? Consumer will reduce the value of semaphore. What is the semaphore? Full value by 1. And it will come to the next statement. What is that next statement? Mutex. Mutex value is 1. That has been sent here again. Now 1 value is less than or equal to 0 is false. So the mutex value has to be reduced by 1. 1 minus 1 is 0. After that, it will go. Now the consumer is in the critical section. What do you mean by in the critical section? Now consumer is accepting this value and it is placing that value in next C variable to for its work. So from this scenario, what you need to understand is when producer is in the, if this is the buffer, and when producer is working with the buffer, consumer has been blocked, or else if consumer is working in the buffer, producer will be blocked. So this is how mutual exclusion has been achieved by using the semaphores, 3 semaphores. What are they? Mutex, full and empty. I hope you all are clear with this simple example of bounded buffer example, which is one classical problems of synchronization. Bounded buffer, why it is called as bounded buffer? Because we have limited number of buffers, or else it is also called as producer consumer problem. Remember, the same problem can be solved by using our traditional approaches of synchronization hardware, that is Peterson solution also. But if you want to have only this semaphores concept, if you want to use, then this is one solution to give solution to that producer consumer problem, where semaphores are used and this is how they will be working. So remember here only our concept here is to achieve mutual exclusion only. We will be achieving only mutual exclusion. I hope you all are clear with this example of bounded buffer producer consumer problem. That is all. Meet in the next lecture. We will meet with the second classical problem of synchronization. Until then, thank you all of you.